two positive numbers multiplying together. And that has to be positive. So don't you agree that this is bigger than 0? FB minus FA is bigger than 0 because it's positive. And that automatically implies what? FB bigger than FA. Okay? But what did we prove? We proved that the starting point is lower than the ending point. It proved that something like this. This is A, this is B. That's higher than that. Okay? Is that we have to prove more. We want to prove this is really. I want to prove it's increasing. I want to really prove this is true. But it's the same idea. You simply apply mean value theorem to what? To f on a different interval. Which interval do we need this time?
Any x?
Yeah, you need an interval. So you pick any. You want to prove this in general, right? In general, you want to prove. You pick any two numbers. If x2 is bigger than x1 inside from A to B, you want to apply mean value theorem to what? To fx on what interval? Can you tell me what interval is that?
x1, x2.
Yeah, you want to apply that to x1 to x2. Does that make sense? Apply mean value theorem to x1, x2, right? And then what do we get? We get fx2, same as before, minus fx1 is equal to, can you tell me what's on the right hand side? Apply the mean value theorem, what would you get?
F prime c.
Okay, f prime of c, and then what else?
X minus a.
Hmm?
X2 minus
x2 minus
x1.
x1, right? No, you don't no longer b minus a. So x2 minus x1, all right? Now, we do know f prime is always positive, so this number is positive. What about that number?
It's always positive.
That's also positive. Why is that? Because we begin with x2 bigger than x1. But that's also positive. Positive comes positive. That's positive. Therefore, this number is bigger than 0. All right?
Why is the interval closed?
Really, I'm not being. I think strictly speaking, you really talk about a mean value theorem to a closed interval, so I could say closed here as well. Yeah. Just like apply the mean value theorem to A equals x1, B equals x2. That's all. Okay, so that's the same as to say fx2 bigger than fx1. Therefore, it is increasing. I feel like I'm creating extra trouble for your folks taking the time's up.
No, it is up.
Let's think about what next. I think this is a good time to start a new section. 3.3. Let me begin with some examples. Okay. Like the example that we have over here. Let's take this example here. Example. This is 3.3 a preview. smell if you want, okay? Just to get an idea of what next. Let's let fx to be x to the third minus 12x plus 2. Determine when fx is increasing and when fx is decreasing. Okay. Remember, increasing means that whenever x2 is bigger than x1, fx2 is bigger than fx1. Decreasing has the same idea. It just means that whenever x2 is bigger than x1, fx2 is less than fx1. That's decreasing. Okay? And in the picture, it just means that it's going up, and here it means it's going down. Right. So, how do we answer a question like this? Well, by corollary that we just learned, if f prime is positive, fx is increasing. If f prime is negative, fx is decreasing. Therefore, all we need to do is to find out when f prime is positive or negative. Okay? So, the first step is to compute f prime x. And then determine when it is positive or negative. F prime x, that's easy. 3x squared minus 12, right? Basically, we want to know when it is positive or negative. To do that, I suggest you first find out where f prime equals 0, or f prime does not exist. So, in this case, f prime exists everywhere, so you just solve for f prime equals to 0. Which means 3x squared minus 12 equals to 0.
Plus or minus 2.
When you take the derivative of 2 is 0. So it disappears. So it's just a minus 12. Right? Once you take f prime, the 2 becomes 0.
Yeah, I meant the answer for x.
Oh yeah,
The
you're
value.
ahead of me. That's right. So x squared equals to 4, right? And x is a plus minus 2. That's correct. Right? Those are the two critical numbers. And I would suggest that you make a table. Let me draw the table here. Actually, it may also help if you factorize this. This is optional, but it helps to do. You factorize this by taking the 3 out. Then you have x squared minus 4, x squared minus 4, and that can be factorized into x plus 2, x minus 2, right? This is the formula. A squared minus b squared equals to a plus b times a minus b. And there you can make a table like this. So you're going to have, this is your straight line here, minus infinity to plus infinity. Then you're going to put your critical numbers beginning from the small ones and then going up. So minus 2 to 2. The first two lines are optional, but I think it will help people. What's important is f prime. Is the next line, which is the f prime, and then the conclusion. So this is your f prime x. You want to know whether f prime is positive or negative on each interval. We already know f prime is factorized into this. So it helps if you know whether that's positive or negative and whether that one is positive or negative. Okay, let's do it one by one. So we'll put x plus 2 here and put x minus 2 here. For x plus 2, this one is 0 at x equals minus 2. And this box means before minus 2, means from minus infinity to minus 2. What is the sign for this? Is it positive or negative? It's negative, right? So you put a negative sign here. After minus 2, is this positive or negative? Positive, right? It's positive and positive here. Okay. Do the same for x minus 2. X minus 2 is 0 when x equals to 2. It's 0 here, and before 2 it is negative. So it's negative here, negative here. After 2 is positive. F prime x is the product of the 2 then times 3. So here you have a negative, negative. We know it is positive, right? Over here is positive, negative. So it's negative. Here is positive, positive. So it's positive.
Wait, you lost me. How did you calculate that now?
You have two numbers, negative and another negative number. Negative times negative is positive. Yeah, you just kind of multiply.
Yeah.
Some people don't do it this way. They just plug in number. They use this one. That also works. Plug in x equals negative 3, for example. And then you get a number. That's 9. That's 27, so bigger than 12, so it's positive. Yeah. You can also do it that way. But I think when you have many factors, doing this way can be very easy to do. So then you can write the conclusion for fx. Here is a positive, that means f is increasing. I'm going to use this notation to denote f is increasing. Negative, therefore f is decreasing, and positive, that means f is increasing. So I have my conclusion. Fx is increasing where?
Negative infinity.
Here, minus infinity to negative 2. So negative infinity to negative 2 and
2 to infinity.
2 to infinity. That's right. Okay. And fx is decreasing on the middle interval. Minus 2 to 2. You can draw a reasonably good picture based on that information. So if you want to draw a picture, I'm just doing extra. The question didn't ask you to draw a picture, but you can do it. So you can say this is the end of your work here. If you want to put a little box there, you can do that, but here is the actual. If you want to draw the picture of fx, picture of graph, I suggest that you do the following. You draw a little table in which you include all the important points. What are the important points? Well, the critical numbers, negative 2 and 2. Negative 2 and 2, and plus any other number you like, anything you like. You can put 0, for example. Okay? You can put your birthday if you want, if you insist, but any number that you like. Okay? So x equals negative 2 gives you, that's negative a, 4, 2, right? Yeah, right? 6, 8, is 18, so that's 18. X equals 2.
Negative 2.
What?
The answer is negative 2.
Negative 2? Okay. Is that right? So it's a negative 14, right?
Negative 14.
So
negative 14